All right, in this video here, we are going to talk about horizontal shifts of graphs, right? So we're talking about transformations of the graphs of functions. I'm doing other videos with the other rules for transformations. This one, I'm just going to be talking about horizontal shifts, but there's other videos I have for vertical shifts and for reflections and stretching and shrinking and stuff like that. So make sure you check out all those other videos as well so you get the complete picture of all the different rules for transformations. But this one just focuses on one single rule, which is the horizontal shifts, right? And basically what we're talking about here is, taking a graph of a function which we call a parent function, and then moving that graph to the left or the right based on a couple basic rules that we have here, right? So for this rule, c is greater than 0. So c represents some positive number, right? So to graph the function y equals f of x minus c, right? So notice it's not just f of x minus c, it's f of parentheses x minus c, right? So if I subtract that number from the x value, it's going to shift the graph of y equals f of x to the right c units. Right, so again, y equals f of x, that's what we call the parent function. I know what that graph looks like, right? So to do one of these transformation graph problems, you need to know what the graph of the parent function y equals f of x looks like, right? So if I know what that graph looks like, and then if I do the graph of f of x minus c, well then that's going to take this graph and basically shift everything to the right c units, right? So whatever number I'm subtracting here, I move that far to the right, with the graph that I know, all right? And on the other side, to graph y equals f of x plus c, I shift the graph of y equals f of x to the left c units. All right, so again, if I know what that parent function looks like, and then I change that parent function a little bit, instead of just f of x, I have f of x plus c, well, that's going to take the graph of the parent function, whatever it looks like, and then move it to the left c units, right? So when I add or subtract a number inside that parent function, it affects the horizontal direction of the graph. Or not the direction, but the horizontal placement of the graph as far as moving it to the left or to the right. All right, so again, that y equals f of x is what we call the parent function. And I actually did a video where I talked about the graphs of 6 different parent functions that are important to know. So if you haven't seen that video yet, you might want to check that one out. It covers 6. It doesn't cover every single possible parent function, but 6 of the more popular ones that you tend to see fairly often. Review that video if you haven't seen it yet, so you know what the graphs of these different parent functions look like. You have to know what that parent function looks like, and then when you add or subtract inside of the parent function, you're adding or subtracting to the x value. And remember, when you're graphing something, x is the horizontal direction, right? The x-axis goes left and right in that horizontal direction. So if you're adding or subtracting inside the parentheses, you're adding or subtracting to that x-coordinate, and so it's affecting the x values, is affecting the horizontal direction. That's why it's moving the graph to the left or to the right, all right? So as I've said in the other video that I do on this stuff, you can memorize the rules, and that's all well and good, but if you understand why the rules are what they are, it makes it easier to work with, and it's less stuff you have to memorize. Like if you understand, well, if I'm adding or subtracting to the x, and the x is the horizontal, well, adding or subtracting the x then is going to affect the horizontal. It's not going to affect up and down. It's going to affect left and right, because that's what the x is the left and right direction, the horizontal direction. Right, now, one thing that's up here, one glaring thing that you may have noticed that I haven't mentioned yet, is that the rules for the horizontal shifts are kind of counterintuitive. They're like the opposite of what you would think. Right? If I subtract c, well, you would think that subtracting would mean moving to the left, right? Because when you're graphing things, minus is to the left, right? Positive is to the right. It's actually the opposite way. So when I'm subtracting a number from the x-coordinate inside that parent function, it actually shifts the graph to the right that many units. When I'm adding a number to that x inside the parent function, it actually shifts the graph to the left, right? So subtracting actually moves to the right, adding actually moves to the left, right? I know it doesn't quite make sense, but when we do an example, which I'm going to erase this in a minute and put up a couple of examples where we actually do horizontal shifts, when we see that example and when I actually have the graphs up there, I'll explain in more detail why it is that subtracting actually moves to the right and adding moves to a left. There is a reason for it. It's not just one of those things you have to memorize because that's the way it is. Like everything in mathematics, there's a reason why the rule is what it is. And if you understand that reason, well, then you understand the rule. And like I just said, that means less things you have to memorize. Getting that understanding is really the goal in learning mathematics. All right, so let me erase this stuff. I'm going to pause the recording, erase it, put up the couple of examples, and then we'll see how this stuff works. All right, we got a couple of examples up here. We have g of x equals x plus 4 squared, and we've got h of x equals x minus 2 squared. All right, and we want to graph those two functions. So when you are graphing a function using transformations of graphs, the first thing you need to do is identify what the parent function is. All right, and in this case, when I have this stuff in parentheses being raised to the second power, and the same thing over here, something in parentheses raised to the second power, that means that my parent function is going to be the second power function, or the quadratic function, y equals x squared. Right, because here I still have an x being squared. I'm just doing something to that x before I square it. Same thing here. I have an x being squared, so my parent function is y equals x squared. All right, so I have a video out there where, I think I mentioned this already here, but I have a video out there where I go through the parent functions and what those graphs look like and some of the key points that are on there. So you might want to check that out to get an idea of the parent functions. But the first thing here is to identify it and then know what the graph of y equals x squared looks like. Now, when you're doing these problems, you don't have to graph the parent function before you graph these functions. I'm going to do that just to kind of show you how they all relate to each other and how you can use the parent function to get these other ones. But again, this part is not necessary when you're actually doing these problems. Right? So some of the key points on the graph of the parent function y equals x squared are 0, 0, right? The point 1, 1, the point 2, 4. And then negative 1, 1, negative 2, 4. Right, and again, all this stuff I kind of explain and go into. Geez, I have a really hard time drawing. That's supposed to be a nice curve. That's kind of a real bad looking graph. I feel like I should probably erase that because it looks so terrible. I'm not really a perfectionist or anything, but that's like ridiculous how bad that looks. All right, so again, knowing what the graphs of the parent functions look like in that other video that I did, I completely missed the point there. On that other video I did, I kind of went through the graphs and how to figure out what those are, and to know, what the graph is, what the graph of y equals x squared looks like, and also those key points that are on there. Like I put 5 points on here, right? You should just know that those are points on the graph of y equals x squared. Let me actually label this y equals x squared so we know that that's what that one is. Now, if you forget those points, you can always just say, well, 2 squared gives me 4, 1 squared gives me 1, 0 squared is 0, negative 1 squared is 1, and so on. So you can kind of put the points together that way. But if you have to do a bunch of these problems on a test, it's kind of a waste of time to have to do that every time. It's a lot better to just know what those points are. All right, so that's my graph of y equals x squared. That's my parent function for these two other ones that we have here. And now I need to, once I know what the parent function is, I identify that, and I know what the graph of that parent function looks like. The next thing is to identify, well, what transformation do I have in this g of x equals x plus 4 squared? Well, since I have that plus 4 happening inside the parent function, right, the plus 4 is being squared along with the x. So when something happens inside the parent function, that's going to affect the x values or the horizontal direction. Right? So that's the next thing, is to identify the transformation. This one is going to be a horizontal shift because I'm adding a number to the x, therefore it is affecting the x values. Right? And the x values are the ones that are in that horizontal direction. All right, so x plus 4. Now here's where this one gets tricky when you're doing the horizontal shifts. You would think, well, x plus 4, that affects the x, and I have to add 4, so that means I move this graph to the right 4 units. It's actually the opposite of what you would think. And if you look at my other videos that I do on the other rules for the transformations of graphs, anything that happens inside the parent function actually has the opposite effect of what you would think. Right? So here we would think plus 4 means move to the right 4 units. Plus 4 actually means to the left 4 units. All right, and after I draw this graph, I'll try to explain why that is. All right, so if I want to graph x plus 4 squared, I have to take the x coordinates of all the points I have on the graph of y equals x squared, and basically I need to subtract 4 from each of those, or take each point and move it 4 units to the left. Right, so if I do 0 minus 4, that gives me the point negative 4 comma 0 on the graph of x plus 4 squared. Right? If I do negative 1 comma 1 and I subtract 4 from that x coordinate, I'm going to get negative 5 comma 1. Right? The y coordinates don't change, just the x coordinates change. I'm basically subtracting 4 from each one of my x coordinates. That's why it's important to know the coordinates of some of the points on that parent function. Then you know which points you have to move around when you're doing these transformations. Right? Negative 2 comma 4, if I subtract 4 from -2, I get -6, which basically takes that point and moves it to the left 4 units. Right, so -6, 4. And then 1, 1, if I move that 4 units to the left, or if I subtract 4 from that 1, I get the point right here, which would be -3, 1. And for the 2, 4, if I subtract 4 units from that, or if I subtract 4 from the x-coordinate, or if I move it 4 units to the left, I actually end up on the same point here, -2, 4. All right, so these two graphs are actually going to intersect at that point up there, which is just a coincidence in this case based on how we moved the graph and what the shift was. That's not always the case, but in this case, those two do intersect at this one point. That's common to both of them. Right, so the purple one up here is my graph of y equals x plus 4 squared. Right, x plus 4 in parentheses squared. All right, so again, adding 4 inside that parent function, inside the parentheses with the x, it affects the x-coordinates of your points on your parent function, and it does the opposite of what you expect. Plus 4 actually moves the graph to the left 4 units. Now, the reason it does the opposite of what you would expect, let's see if I can explain this in a way. It makes sense to me, but trying to explain it in a way that makes sense to other people is not always easy to do. So, think about this point on the parent function 0, 0. Right, so when I plug into my y equals x squared, when I plug in x equals 0, I get y equals 0. Right, so that gives me the point 0, 0. Well, what number do I have to plug into this function here so that I end up with y equals 0? Well, it wouldn't be 4, right? Because if I do 4 plus 4, that's 8 squared, which is not equal to 0. To make this equal 0, like this one did, I have to plug in x equals -4. Right? -4 plus 4 gives me 0 squared, which gives me 0. That's why this point becomes -4, 0 instead of +4, 0. Right? That's why it moves to the left rather than to the right. Right? To keep that same y value, I have to put a -4 in for x instead of a +4. Right? And same for all the other points. Like to get a 1 here, right? To get a y value of 1, like when I plug in x equals 1, I get y equals 1. To get a 1 here, I would have to plug in x equals a -3. Right? -3 plus 4, that gives me 1 squared, which gives me 1. That's why this point moves to the left 4 instead of to the right 4. Right? So that's why when you're adding or subtracting inside that parent function, it goes in the opposite direction. To get the original point, you have to put in the opposite of the number you have here. If I have a +4 here, I need to put a -4 in for x in order to make that equal the 0 that it equaled over here before. Right? Which is why it moves to the left to -4, 0. Right? Hopefully that makes sense, but that's the reason why the rule for the horizontal shift is the opposite of what you would think. Right, to do this one here real quick, we only got a couple minutes left for this video, but h of x equals x minus 2 squared. Right, so once again, I already identified that my parent function is y equals x squared. That's the blue one up here. I know what that graph looks like. Now identify the shift, or the transformation, which since it's a -2, inside the parent function, inside the parentheses with the x, that affects the x direction, and it's the opposite of what you would think. So -2 actually means move to the right 2 units, right? In order to make y equals 0, I would have to plug in x equals +2, not x equals -2, right? So my vertex point moves to the right 2 units at the point 2, 0. Right? Again, plugging in x equals +2 gives me a y of 0, right, when I do those calculations. All right, so basically every point that I have on here gets shifted to the right 2 units. So 1, 1 comes over here and becomes 3, 1. Right? I'm basically adding 2 to this x-coordinate, keeping the y-coordinate the same. Right? -1, 1, if I add 2 to -1, I get +1. So you see these graphs are also going to intersect here at the point 1, 1. Let's see, 2, 4, if I add 2 to the x-coordinate, it's going to become 4, 4. -2, 4, if I add 2 to the x-coordinate, it becomes 0, 4. All right, so you can think about it 2 different ways. You can think about it as, when I see this x minus 2 squared, that means it's a horizontal shift to the right, so I either add 2 to all of these x-coordinates that I know from the parent function, right? So every single x value gets a 2 added to it, and that gives me the new point. Or you think about it as, I just take this blue graph and all those points on there, and I shift every single point 2 units to the right, and that gives me the black graph up here of y equals x minus 2 squared. Right? And notice, all 3 of these graphs have the exact same shape. They're just in a different position based on what numbers being added or subtracted inside that parent function. All right, so horizontal shifts, the numbers added or subtracted inside the parentheses, inside the function with the x, that affects the horizontal direction, and it actually goes the opposite of the direction you would think that it would go. Make sure you check out my other videos on transformations.